Intermediate Value Theorem for polynomials. Here's the definition. If f of x defines a polynomial function with only real coefficients, and if for the real numbers a and b, the values of f of a and f of b are opposite in sign, then there exists at least one real zero between a and b. Okay, so there is a note here, at least one real zero. I would say one real zero only. And there's a important key word here, it's opposite in sign. Again, it's opposite in sign. So that's the rule here. So if they're opposite in sign, there is one real zero between a and b. And a is an x value. So that's your a. And b also is an x value along the x-axis that you have to pick. So between them, there will be a real zero if you can see an opposite sign. Otherwise, they have the same sign, in which you can conclude that there's no real zero in between those two values. Okay, so it's like this is an example. This is your x-axis, and let's say your a is equal to 1 and b is equal to 2. Let's say the curve actually is passing through here and there is a 0 in between 1 and 2. So what the theorem said, the sign should be opposite. So when you test this out using f of a, then you will say have here a positive, for example. And then for f of b, you will get a negative. So if they have opposite sign, it means there is a 0 in between these two values. Or it could be the other way around. It could be negative here and positive here. Okay, so that's what it means. So let's have an example. Okay, here's you have to use synthetic division and a graph to show that f of x equals x cubed minus 2x squared minus x plus 1 has a real 0 between 2 and 3. So it says has a real 0, so it means when we evaluate this using this method, synthetic division, again using synthetic division, you are going to get opposite sign here. That's the expected value. Okay, so let's try that. So we will put 2 as our k here, and we will have the numbers beside the terms. So we have 1, negative 2, and negative 1, and then 1. So it should be in descending order. So we have here a 3, a 2, a 1, and then the constant term. And then draw a long horizontal line and drop the first number. So 1 is here. Multiply 1 to your k, which is 2. That gives you a 2. Add this, it gives you a 0. Multiply 0 times 2. You'll get a 0 here. Add that again. It gives you negative 1. Multiply this again. Negative 1 times 2. That's a negative 2. And then adding this, it gives you a negative 1. So we're looking at the remainder here. So this is our remainder. And then we will test 3 as our k and use the same f of x, okay, and do the same thing as we did in the first part of the solution. So bring 1 down. 1 times 3 would be 3. Adding this would give us a positive 1. 1 times 3 is 3. Adding this, it gives you a positive 2. 2 times 3 is 6. Adding this, it gives you a 7. So here's the remainder for the other one. So um, we have our f of 2 here, f of 2, and our f of 3 here. And just look at the sign. So here we have a negative, and then the other one has a positive. So doing that, if you have a negative and a positive, it means, therefore, we're going to say that uh, there is a real zero between, okay, there is a real zero that's between the value 2 and 3. So between 2 and 3. So that would be our conclusion. If your f of 2 and f of 3 have the same signs, then you can say that there's no real zero in between 2 and 3. Okay? Another way to do this, if you remember, if you're comfortable using a different way, you can actually use the remainder theorem. So using remainder theorem, you can also evaluate this. So say you have f of 2. I'll just plug in 2 to our x here from the f of x. So 2 power of 3 minus 2 times 2 times, or power of 2 minus 2 plus 1. Okay? And then we evaluate. So here you can see this is 8. You have 4 times 2, that would be a minus 8. Then minus 2 plus 1. 8 minus 8 is a 0. Negative 2 plus 1 is a negative 1. You can see that our remainder here is the same as the remainder using synthetic division. So this is the alternate solution here. So f of 3 equals, we're plugging in 3 now instead of 2 to test. So again, we're after with the sign only here. So 3 power of 3 minus 2 times 3 power of 2 minus 3 plus 1. Okay, and then evaluate. You have 3 times 3 times 3, that would be 27 here, minus, you have 3 power 2, 9 times 2, 18, minus 3 plus 1. Okay, so 27 minus 18 would be a 9. 9 minus 3, that would be a 6. 6 plus 1 would be a 7. So 7 is the answer here. So that's exactly the same answers we got using synthetic division. In this case, we're using remainder theorem here. So remainder theorem actually is the alternate solution here. So you have a negative, and then it turns to a positive here. So it means, therefore, there is a real zero. Okay, the 3 dots here represents therefore. So there is a real zero, okay, between 2 and 3, between 2 and 3, okay. So that's the answer, okay. And then we will show you the graph for x cubed minus 2x squared minus x plus 1. So let's show it to you next. Okay, you can see that there are 3 zeros here. There are 3 x-intercepts. So you have a negative real zero and you have 2 positive real zeros here. So looking at uh, graph, this is the negative real zero here, first one. And the other one here is the second positive zero. That's the second zero, which is the first positive zero. And then the second positive zero, which is the third zero here. So there are 3 since we have a power of 3 there. And if you're trying to analyze, you're looking at this point here, 2, this point 2 here, and that 2, it's our A, and the next one is 3. So in between the value 2 and 3, there is uh, 1 real zero. So that's what it means with our calculation here. Okay. So let's say you have to work with f of 4. So you have already f of 3. Note that you have f of 3 already calculated. And if you take f of 4, then in between those two values, then there's no 0 here. So let's see what happened if we will do that. Okay. So what we did a while ago, we calculated our f of 3, f of 3, and our answer was 7. So that's a positive 7. Now we will calculate what is f of 4 to see if in between these two values you have a 0 or not by using the theorem. So we will use the same function. Okay, our function f of x, let's write that out. It's equal to x cubed minus 2x squared minus x plus 1. Okay, and then let's plug in 4, power of 3 minus 2, you have 4 here, power of 2 minus 4 plus 1. Okay, what we're doing is just plugging in our value 4 to our x here. And then we calculate. So that would be 4 power of 3. It gives us 64. So we have 64 here minus, we have 4 times 4 is 16, times 2 is negative 32. And then minus 4 plus 1. And then 64 minus 32 is 32. Minus 4 is 28, plus 1 is 29. So as you can see here, our f of 4 it's 29. And we have 7 here for f of 3. So if you have to apply the theorem, this is a plus sign here and a plus, there's no opposite sign here. So you can make a conclusion, therefore, um, there is no real zero between 3 and 4. Okay, so as you can see from the graph also, there's no zero there. So that's how we test using the intermediate value theorem. Again, you can use either a remainder theorem or synthetic division to evaluate if there is a real zero. Now, most likely, if you have two real zeros in between those two values, the theorem cannot be applied because it will be sometimes the same signs instead of having opposite signs. So the theorem most of the time can be applied if you have only one zero in between the two values you're trying to test. Okay, so I want you to look at one more time the graph. This is what we're looking for, the value uh, 3 and 4. So we're going to put up again the arrow graph a while ago and see that part of the graph. Okay, and looking at our graph here, here's the 2 and the 3, and there is 1 for the first example, 1, 0. But on the last test, we have the 3 and the 4. So in between where x is 3, and that is our a equal to 3, and x is equal to 4, where's that's our b value. There's nothing, there's no zero in between the two values here. So you can also test if you want the 0 and the 1 here. Obviously, if you test 0 and 1 here, there is a 0 here. So it means you will have an opposite sign. So you can test that. You take f of 0. We already have uh, f of 2. You can have f of 2 also. But you can take also f of 1. So f of 1, take that and f of 0. Then you will have opposite sign. So even if you have f of 0 and f of 2, you still have an opposite sign because you have only one 0 in between them. So this is the one here. Okay, so think about intermediate value theorem is just knowing or finding if there is a 0 in between the two test values, which is your a and b. That's along the x-axis.